The History and Features of the Grand Canyon by Micah Cheshire. The oldest rocks in the Inner Canyon. So these down here are basically the Inner Canyon. So in the Grand Canyon, there's a canyon within a canyon. And so these inner layers from oldest to youngest are the Precambrian basement, the lower unconformity, the late Precambrian, and the upper unconformity. The Grand Canyon consists of 7 sequences of rocks. The oldest rocks are at the bottom and the youngest are at the top. The oldest rocks are 1.7 billion years old. They're metamorphic rock and granite. These hard rocks are exposed in the bottom of the canyon, forming a steep and narrow inner canyon. After these oldest rocks were formed and metamorphosized, they were uplifted and eroded over hundreds of millions of years. This erosion formed the lower unconformity. An unconformity shows a time of erosion, not deposition. It's considered to be a gap in the record of events because no layers were deposited to indicate what occurred at this time. So after the upper unconformity, layers in the late Precambrian rocks tilted and were rounded by erosion, and then the upper conformity formed. After erosion carved the upper conformity, various processes deposited the sedimentary layers that form the main walls of the Grand Canyon, which are the layers of Paleozoic rocks. So after the upper conformity formed and was eroded, the top 3 layers of what is considered the main Grand Canyon was formed. So layer 1, 2, and 3, the late Paleozoic, middle Paleozoic, and early Paleozoic. Each Paleozoic layer has a different resistance and response to erosion, which is what creates the staggering stair-step look of the Upper Canyon. These sedimentary layers show a wide range of environments. They are dated with marine and non-marine fossils. The entire Paleozoic time era formed between 250 to 550 million years ago. The sedimentary layers have largely escaped deformation and remained nearly flat. So this graph or image is just kind of showing the broad look of the layers of the Grand Canyon. And so how I said there was a canyon within a canyon, so after that last unconformity, so there's 2 unconformities, there's that inner gorge, and this is the inner gorge right here, with the Colorado River at the bottom. So plateaus and basalt flows. The Colorado River flows from right to left, entering Lake Mead in the west. The Colorado Plateau is a region of broad plateaus and deep canyons with mostly flat surface tops. However, basalt flows cap some plateaus and predate the formation of the main canyon. So this is what I'm talking about with the basalt flows. So this right here is a plateau, and it would have been flat, but the basalt flow is that curved higher top on top of the plateau, and then right here is we're at the bottom of the canyon, and this is the Colorado River. Right here, the really big wall above me, we can know that it is early Paleozoic because of the limestone and sandstone, and the limestone that makes up the early Paleozoic is the Kaibab limestone. Right here is an alluvial fan. An alluvial fan is a mass of clay, silt, sand, and gravel deposits as the flow in a river decreases in velocity. So in this case, it's where the Colorado River slowed down and where all this clay and silt and gravel had stopped, and it forms this fan-shaped flat space within the canyon. It influences the habitat along the Colorado River at the bottom of the Grand Canyon. I also wanted to include the Horseshoe Bend and the Antelope Canyon. The Horseshoe Bend is at the eastern rim of the Grand Canyon, and it's where the mead of the river, so which means it curves, and it eroded all the rock right here except this really huge rock in the middle. And this right here is the Antelope Canyon, and it was also formed by water. It was formed by flash floods millions of years ago, and it was also very close to the Grand Canyon in Arizona. Thanks for watching.